Hello friends, today we will discuss one more example on divergence and curl of vector. So let's start the example. But before example, one important note, that is note number 1. Curl of a vector f equal to 0, then it implies field is conservative. This important note is useful in next example. So let's start first example. So first of all, read the question and decide that what we have to find and what is given here. So here given that vector f is equal to 2xy plus z cube I plus x square z plus 3x z square k. Say equation number 1. Now in this question, what we have to find? So to find in the same question, first of all we have to show that given vector field f is conservative. So first we have to find first in this example, to show vector f is conservative field. Again in this question, the second part is to find the scalar potential, that is second, to find scalar potential denoted by phi. And the last one, in the same example, we have to find work done. So let's start first case, that is to show f is conservative field. To show f is conservative field, we have to show curl of a vector f is 0 by using note. So we have to show curl of vector f equal to 0, that is to prove del cross f equal to 0, because by definition curl of a vector f is a del cross f. So let's start from left hand side, del cross f. So now del cross f is nothing but determinant ijk, to find the cross product we have to find the determinant, where second row is del by del x, del by del y and del by del z, and in the third row the components of vector f, which is given in equation 1. So components are 2xy plus z cube x square, and in the last it is 3x z square. Now by solving this determinant, we will get I times del by del y of 3x z square minus del by del z of x square minus j times. Now for j, we will remove the row and column of j. So it is the del by del x of 3x z square minus del by del z of 2xy plus z cube plus k times now del by del x of x square minus del by del y of 2xy plus z cube. After simplification, it is equal to I times derivative of 3xz square with respect to y. Why? We know that with respect to y, x and z are constant. So it is 0 minus now derivative of x square with respect to z. For variable z, x is again constant. So derivative is again 0 minus j times. Now derivative of 3x z square. Here x is present. So derivative is 3z square minus now derivative of these with respect to z. So with respect to z, derivative of 2xy is 0 plus derivative of z cube, that is 3z square with respect to z plus 3 times now derivative of x square 2x minus derivative of this with respect to y. So derivative of 2xy with respect to y, it is 2x plus derivative of z cube. Z is constant for y, so it is 0, which is equal to, now it is again 0, 3z square minus 3z square gets cancelled. Now 2x minus 2x again cancelled, so we will get 0, that is 0 vector. Therefore del cross f equal to 0, that is curl of vector f equal to 0. Therefore given field f is conservative. Hence first part is proved. Now move on to the second one. Second, to find scalar potential phi, we have gradient of scalar is equal to vector. Now in notation or symbol, we can write it as del of scalar, that is phi, equal to vector, but here vector given is vector f, so it is equal to vector f. Therefore now del dot phi, which is gradient of phi, by definition it is del phi by del x I plus del phi by del y j plus del phi by del z k, and it is equal to vector f, which is given in equation 1, that is 2xy plus z cube I plus x square z plus 3x z square k. Now on equating coefficient of I, j, k, we will get del phi by del x is equal to first coefficient of phi 2xy plus z cube, say equation number 2, and coefficient of j, that is del phi by del y, it is equal to x square, say equation number 3, and finally the coefficient of k, that is del phi by del z, is equal to 3x z square, say equation number 4. Now to find the scalar potential phi, that is to find the scalar potential phi, we have to integrate this, because integration and derivative will get cancelled and we will get the scalar potential phi. So let's integrate equation 2, 3, 4. On integrating equation 2, 3, 4 with respect to x, y and z respectively. So first integrate equation 2 with respect to x. We will get 2 implies. Now integration of del phi by del x with respect to x, it is phi equal to integration of 2xy. So 2y is constant, but integration of x is x square by 2 plus integration of z cube. So z cube is constant into x plus constant of integration, say c1. Here 2 gets cancelled, therefore phi is equal to x square y plus z cube x plus constant of integration c1 can be written as f of y comma z. Here I have written f of y comma z in place of constant c1. Why? Because we have integrated equation 2 with respect to x, and for x and with respect to x, y and z are constant. So we have taken f of y comma z as a constant c1. Say equation number 5 again, and 3 implies. Now integrate 3 with respect to y. We will get the phi which is equal to, now integration of x square. So it is x square y plus constant c2. Therefore phi is equal to x square y plus constant c2 can be replaced by f of x comma z. Again we have integrated these with respect to y, and for y x and z are constant, so we have replaced c2 by a function of x comma z. So equation number 6. Also equation 4 implies. Now integrate equation 4 with respect to z. So it is phi equal to 3x constant integration of z square is z cube by 3 plus constant of integration say c3. So after cancelling 3, we will get phi equal to xz cube plus f of x comma y, because with respect to z, x and y are constant, so constant c3 is replaced by f of x comma y. Say equation number 7. Now in order to find the complete solution scalar potential phi, we have to find constant f of y comma z, constant f of x comma z and constant f of x comma y. So let's see how to find this constant. Here first constant f of y comma z, it is equal to terms of phi independent of x. So function y comma z, it is terms of phi independent of x. That is, we have to write those term of phi in which x is absent. So from equation 5, 6, 7, here x is present, so skip it. Here again x is present, so skip it. Now in equation 6, again x is present. From equation 7, again x is present, so f of y comma z equal to 0. Now second constant, that is f of x comma z, which is equal to terms of phi independent of y, that is terms of phi which does not contain y, it is equal to, again we have to check that the terms which does not contain y. So in this equation 5, here y is present, but here y is not present, so we have to write this term here. So it is z cube x. Now again we have to check other equation. Here y is present, here is y is not present, and we have already written this term z cube x, so we will not repeat this term. Next, finally, f of x comma y. So it is equal to terms of phi independent of z. So it is equal to, now again check equation 5, 6, 7 where z is absent. So in this equation there is no z in this term, so we will write here x square y. Now here z is present, here z is not present, but we have already written x square y, so we will not repeat. In the last equation again z is present, so this is the constant f of x comma y. Now after putting these constant in equation 5, 6, 7, we will get the complete solution. So put f of y comma z in equation 5, it implies 5 implies phi equal to x square y plus z cube x plus f of y comma z, which is 0. Therefore required solution is x square y plus z cube x is the required solution. Also, if we put f of x comma z in equation 6, we will get phi equal to x square y plus f of x z, which is z cube x. So again it is same as that of previous one. After that, if you will put f of x comma y in equation 7, then again you will get the same solution. So it is required solution, say equation number 8 is, that is phi of x comma y comma z equal to x square y plus z cube x is required solution, is required solution. Now move on to the third part. Third, to find work done. We know that in conservative field, work done in moving object or particle from one point say point A, which is given here 1 minus 2 comma 1 to point B, which is given as 3 comma 1 comma 4 is equal to, now in conservative field the work done depends on endpoints A and B and not on the path or the complete procedure. So it is equal to difference of endpoints, which is given by the formula integration d phi from A to B, which is equal to integration of d phi, that is phi, within the limit A to B, which is equal to phi of B minus phi of A. So in conservative field, the whole work done is nothing but the difference of scalar potential at endpoints, say here B and A. Now we will find phi of B and phi of A from equation 8 by putting the values of B, that is 314 and 1 minus 2 1. So let us calculate this. Work done W equal to phi of B, that is phi of 314 minus phi of 1 minus 2 1. So it is equal to, now by using this formula we will calculate here x y z. So x square y that is 3 square 9 into 1 plus z cube x, so z is 4 cube, that is 64 into x, that is 3, so that is phi of 314 minus, again it is x square y, so x square that is 1 into y, which is minus 2, so it is minus 2 plus z cube x, so z is 1, z cube is 1 into 1. So after calculation we will get 9 plus 192 minus 2 plus 1, that is minus 1. So we will get, it is 201 plus 1 equal to 202. So this is the required work done in moving particle from point A to point B in the given vector field. Friend, here we have calculated the work done in conservative field. Suppose it was non-conservative field, so I am giving hint for non-conservative field. For non-conservative field, the work done W is equal to the line integral over the curve into f dot dr.